Acids and bases. Acids and bases. I'm going to do a little experiment here. I'm going to see my water. I have well water, so I want to see how it's doing. I chemically add some things in it to make it less acidic, because out of the ground it's a little acidic. Probably full of nutrients, minerals and such. But aside from that, can't have it eat the copper pipes, so I have to add a little soda ash, and then it lowers the pH. Okay, so let's see how we're doing here. I'm going to take this here. This is the indicator. Shake it up, and I have my regular water in there. I have the meniscus right. I'm going to add 5 drops. 1, 2, 3, 4, 5. I'm going to shake it up, and I'm going to see what's the story in a few minutes with that. Another version is you can buy these indicator strips, and there's my water as well. Stick them in for a few seconds or so. Okay, and let them come out. And you're going up against these known, I don't know, these indicator strips are pretty old, so the pH here would be the second one. See, the first one is telling you free chlorine. Of course, it's low to none. But then the second strip you read here, and I have 6.2 at least. It doesn't look like 6.8. I don't know, but these are old. So this one's going to be more accurate. So let's see. What do we see here? I see 7.2. It looks like, which is ideal. It's surely more than the 6.8. So it's my the pH of my water is between 7.2 and 7.6, which would be roughly neutral, and that's a good thing. Just taking another look at this strip. If you notice, it's not exactly that color, but it is that color. So it's about 6.87. See? There you go. Okay, so my water is fairly neutral. Now let's get down to acids and bases, okay? And we're talking about the properties of acids and bases. All right, so I'm going to just go over here, acids and bases on the right. What are some acids and what are some bases? How about vinegar? Okay, also known as acetic acid. How about most citrus fruits? All right, your oranges and things of that nature. Many carbonated drinks. Contain these kind of things, and that would make them acidic. How about battery acid? Well, that's an acid, right? It says it in the name. Many people don't realize that tea is an acid. Some people get upset stomach from tea. It's some kind of tannins or something inside of it. Okay, so foods that give a tart or sour taste. Okay, stuff like that. Now let's look at some bases, okay? One popular one is antacids. if you're older, Antacids is pretty good, because this neutralizes stomach acid. You see a lot of old people popping these Tums and things like that. Okay, many household cleaning agents. Okay, bleaches and things like this, or the stuff you put down your drain to unclog your drain. Okay, nasty stuff. Okay, let's see. So soap. Okay, if you have a slippery sensation or feel, okay, typically that's a base. All right, you could feel that with bleach on your hands, okay, or even soap. Okay, bleach or soap, slippery feel. All right, most all foods you eat are not bases. Okay, most foods are acids that you eat. So your gut's full of acid, hence why people are looking for this stomach acid. And a key word here is neutralization reaction, as we will learn at some time later. So what happens when you take these acids and you put them in water? Okay, an acid plus water, okay, is going to give you electrolytes. And electrolytes are ions. Okay, and what are ions? That's the things where you see H plus or something like that, right? Or any other ions, right? Ions are when you have the positive or the negative, in which case this is also true here. Acid plus, bases plus water also give you electrolytes. So you're getting both these. But over here it's plus, H plus, and over here it's OH minus is the first definition. We're going to talk about Arrhenius acid, Arrhenius base in the next video. But these ions, okay, are H plus or OH. They have a charge. And by the way, this charge conducts electricity. Hence ions. Okay, these conduct electricity. So both the acids and the bases plus water give us electrolytes. In case of bases, we're getting the OH in this particular initial definition, and in here we're getting the H pluses. Okay, definition we will find out soon is the Arrhenius definition of acids and bases. Okay, so now there's some strong electrolytes and there's some weak ones. So we're going to find out there's stronger ones and weaker ones. We'll get to the bottom of that. But in the acid, some examples. And some examples over here of the base. Okay, we're going to find out that HCl is a acid, HNO3, H2SO4, H3PO4, Okay, H2CO3. All right, what's this guy? This is hydrochloric acid. Okay, this is nitric acid. This is sulfuric acid. This is phosphoric acid. Okay, I finished off with phosphoric acid, H3PO4. Then I have carbonic acid, H2CO3. Okay. Stronger acids would be these three, the HCl, NO3, H2SO4. And weaker acids would be the H3PO4 and the carbonic acid. All right, and finally, onto the bases, we have KOH, NaOH, Ca quantity OH taken twice, Mg quantity OH taken twice. This one would be potassium hydroxide, sodium hydroxide, calcium hydroxide, magnesium hydroxide. So you see this OH is the hydroxide ion, right? Minus. I want to make it clear also, these are all strong bases rather, and in that potassium and sodium are from your group 1A metals, right? And your calcium and magnesium are from your group 2A metals. And lastly, I say, so if you add an acid and a base, you get a water and a salt. Imagine that. So you're adding but if you put the two together, it's a neutralization reaction, and you get a water and salt, something you could just drink down, and I guess the salt will make you a little edgy. But other than that, you'll be okay. All right, and so what's this guy? According to the Arrhenius definition, which we're going to cover in more detail in the next lesson, it's a H plus, right? Which is nothing more than a what? Proton, right? H plus is a proton ion. And then this guy here is the hydroxide, right? Hydroxide. And that ion is the OH. Both of these are electrolytes. They conduct electricity. And putting them together, well, what do you got? You got two H's and one O, H2O, right? And whatever was associated with this guy, and whatever's associated with this guy combine together and become the salt. All right, we'll talk about that another time. And one more thing, I think. Anyone ever taste soap? I did when I was a kid. If you made any foul language, your mother and father washed your mouth out with soap. So not a good thing. Very taste terrible. How to end with that one. Okay, have a good day.